he's doing, and I do feel Xiaoyu's career is on this big trajectory at the moment. There's grants coming in, papers, lots of activity, and more than that, perhaps the key thing that he addresses is becoming more and more important in when we think about sustainability. So there's all these dangers in replacing one thing, we create another monster for the future, and I think that's where your work is really invaluable. So we all want to get rid of plastics, but we create a new material without thinking through the consequences of that, the energy embedded in it, that round of waste, what we're going to do with it. So the idea of life cycle analysis, I know he's going to talk about, is incredibly pertinent, important. And as a geographer, actually, one of the things we often tend to do is say we're solving the sustainability problem by shoving problems to other countries where we can't see the consequences of it. So this notion of unintended consequences is really important in thinking about sustainability solutions. So it's brilliant to have you do the talk today. Xiaoyu's going to talk for 30 minutes, and then we'll have 35 minutes, then we'll have time for Q&A. If you want to stick your hand up when he finishes speaking, or just put a note in the chat, then I will try and make sure I come to you, but also just butt in if I don't. And I did want to say that Xiaoyu is one of our longest serving members. He actually joined the ESI in January 2013, before the official opening. So is well known to lots of people in the ESI. But is a key linchpin, I think, of our community, because he's somebody that does speak right across all the disciplines and all the issues in our building. So he's a brilliant ambassador for what we're doing in the ESI. So a big thank you as well for what you're doing. Enough from me, over to Xiaoyu. He's going to talk, and then we'll have our Q&A. So thanks.
Thank you, Jen. Thank you for starting this great initiative. You know, it's always a pleasure to share our research with our colleagues and friends. And I do realize that I haven't done this for quite a while now. As you said, I started nearly 8 years ago. I think probably the last time I did this was actually not long after I joined the ESI, actually. So it's been a while. So today I'm going to talk about something that I've been working on for the last 15 years, which is quantifying environmental performance. And by human systems across socioeconomic scales, I really mean everything we produce, everything we consume and do, as individuals, as organizations, as nations, etc. Really, before I move on to that topic, I thought it might be useful to give a kind of quick overview of how I got here, doing what I do. I will then give a brief introduction to the kind of method that we use to quantify environmental performance. And after that, there's really 4 key messages I would like to get across, using examples from past and ongoing research in my group. And finally, I will end by sharing a few thoughts on future directions in this area. Now, my journey to the ESI. So I grew up in a small city called Zhoukou, here in central China, roughly where this black dot is. And then I went to Shanghai to do my undergraduate in one of China's best universities, before I came to the UK in 2004. I then did my PhD at Queen Mary, University of London, and some postdoctoral research in Oxford and Cambridge before I moved down here, as I said earlier, early 2013, shortly after the ESI was formed. And I was trained as an engineer, and my undergraduate was in transport engineering, and I learned how to design and manage transport systems, you know, beautiful bridges like this, roads, tunnels, fancy flyovers, that kind of thing. And I was planning to work in these areas after I graduated. There was a lot of demand for our skills as China was expanding its transport infrastructure massively at the time. But in my last year of undergrad, an important man Roy Crookes, pictured here, came into my life, largely by chance, actually. Roy was a professor in mechanical engineering at Queen Mary. He was on a trip in China to give talks at a few Chinese universities. To cut a long story short, I was acting as his translator and guide during his trip. And one day we sat in this really awful traffic jam. You know, back then cars were just beginning to enter average families in China, so the number of cars was really kind of rocketing, and traffic jams became a common thing. I remember I said to him, I'm going to build more roads and flyovers to solve these traffic jams, you know. And he asked me, how are you going to feed all these cars? I said, well, I don't know. I never thought about it. Maybe, you know, import oil from other countries, I guess. And then he mentioned an alien thing, or alien thing to me, at least. And he said, you know, biofuels could be an option. You know, fuels made out of plants. And I was like, what? But that day I learned a lot about biofuels, and they really fascinated me. Actually, they fascinated me enough to come to the UK to do a PhD with Roy. So I started doing what Roy did, you know, in the best part of his career, which is testing different biofuels on automotive engines. But before long, you know, after I think a couple of months, I told Roy I don't want to do this anymore, and he was pretty shocked. Eventually accepted, of course. But the reason I did this was not because burning stuff wasn't fun. It was fun, actually, even though it's a bit noisy and smelly, and you know. But it was because I found an increasing number of studies that questioned the sustainability of biofuels. And that really worried me. So I ended up investigating the life cycle emissions of different transport technologies, you know, from combustion engine powered vehicles burning all sorts of fuels to battery electric vehicles filled with different types of electricity and hydrogen fuel cell vehicles, etc. And also kind of assessing whether you know, biofuels and many other technologies and policies can actually reduce emissions overall in the long run. So effectively, I became an analyst. I never looked back since then. So after I moved here, I sort of gradually built up a team of researchers to work on topics around energy, environment, and economy, the 4E groups, as we call it. We work with many colleagues in engineering, CSM, maths, within SAMS, but also many colleagues in class and business school. The overarching aim of our research is to help people make better decisions, make more informed decisions, be them governments, businesses, or just citizens like ourselves. And our research really has four kind of main pillars: technologies, economy, environment, and human. And we use this sort of whole systems thinking to try and understand the complex relationships between these different pillars. And this involves different approaches, such as what's shown on here, you know, sector-focused scenario analysis, the nexus, which is a very hot topic in the last couple of years, basically how different sectors are intertwined. The water, energy, food nexus is just the most common one, but there are many other nexuses. Circular economy, how we can make our whole economy more circular rather than linear. And underpinning pretty much all of our work in these areas is life cycle sustainability assessment, which is what I'm going to mainly talk about today. So this all stems from the question of how we actually quantify environmental performance, because it's obviously very important that we understand what we do and the consequences. And this could be something that companies are thinking about. For example, actually this whole method, ironically perhaps, was pioneered by a company that many would think as the most polluting company in the world, Coca-Cola. So back in the late 1960s, Coca-Cola was actually pioneering the use of what's now called life cycle analysis, or LCA, to analyze, for example, what should they use to bottle their drinks, whether that's metal cans or glass bottles or plastic bottles. And you can see that we're still struggling with this problem even till today. And it could be something that every single one of us is thinking about, whether we buy something or another thing, an alternative, what's the best option. It could be something like how we deal with our waste and where we get our energy from as a society, as a country. So all of these questions needs some sort of tool that we can quantify and compare them. And that's what LCA, so life cycle assessment, is really about. It is an internationally standardized tool to quantify inputs and outputs from any product systems, it could be anything, and assess the associated environmental impacts over its entire life cycle. So here you can see an example. Basically we look at right from the extraction of raw materials all the way to manufacturing, to the use, to end of life. And we need to take into account all the inputs. By that I mean resources like raw materials, energy, water, etc. And the outputs, which are mainly the waste and emissions. And this is a these days, very standardized method. So there's a series of ISO standards, and you need to follow these steps to do an LCA. So I will kind of briefly go through them so that you understand how this is done. So the first step really is asking the question, what is the goal of your study? What do you want to achieve? Whether it's to identify the hot spots over a particular product life cycle, or whether you want to compare different options, different technologies. And you need to describe your system, obviously, whether it's a product or a household or a country, anything really, as long as you define it clearly. And then you need a functional unit, especially if you want to compare different options, because you have to compare them based on the same basis. For example, it could be a kilowatt hour of electricity generated if you're comparing different electricity generating technologies, or it could be 1 kilometers transported if you're comparing different transport options. And then you need to define the system boundary, what activities and processes you need to include in your whole life cycle. And also you need to sort of be clear about what impacts you're looking at, whether it's climate change, so carbon footprints basically, or water footprints, or land use, etc. There's a whole range of impacts we can look at, and that will determine what kind of impact assessment method you need to use in your LCA. And then the next step is what we call life cycle inventory. Is compiling the input data into your model. And LCA, in essence, is a matrix of inputs and outputs. mathematically at least. So you can see here, basically you have a huge matrix of all these different inputs for each process over the entire life cycle. And this is just a very simplified life cycle that you only have, a handful of processes. But in reality, usually there's dozens, hundreds, even thousands of processes involved. So it's a huge matrix of inputs and outputs. And this is very difficult to gather the data, and I will tell you how exactly we do this a bit later. And once you have these inputs and outputs, it's effectively just these numbers, really. You then need to turn that into some sort of impacts. So here I'm showing a few examples, but this is not an exhaustive list. So it can be global warming, for example, which is an indicator of climate change impact. It could be land use, water use, as I said earlier, a whole range of different impacts. And the way to calculate these impacts from the inventory, from the resource and emissions, is to use these so-called impact characterization factors. So essentially, they're all based on quite complex environmental modeling, of course, but in LCA, they're a very simplified number. So by that factor, you can turn these inventories into the impacts. And as I said earlier, we need powerful tools to analyze the stuff that we now need to analyze because of the increasing complex nature of these products. So these are the things that I play with when I was a little boy. And these are kind of things that my son play with these days. So these products have very complex supply chains, and they need a lot of different kind of materials, elements, etc. So the number of processes we need to look at for analyzing these different products is really huge. So we need good, powerful computer-based tools to do that. And here I'm showing a few examples of the tools that we use in our group. So SimaPro, Gabi, and OpenLCA. So these are all lifecycle assessment software. And of course, you need the databases as well, which are the inventory databases, which describes what are the inputs and outputs of particular processes. And then you put these processes together to form different products. So in this case here, given as an example, a laptop computer, and you can see the different sort of components of that computer, and then you can trace it all the way back to the raw material. And this graph here gives you an idea of the life cycle network of processes that are involved in producing this laptop computer here. And actually, this network graph only shows about 85 processes. So each box on here is a process. It only shows 85 processes out of 14,000 processes that are interlinked in our database. And this is why we need these powerful tools to do all of these matrix inversion and multiplication, because it's huge matrices that we're talking about. So really, that's in a nutshell what LCA is about, and we can use it to analyze different products, at different scales, and of course, scale, the more complex it becomes, and probably we'll lose some details because we can't possibly model everything. And the database, even though they contain more than 10,000 processes, they're still not enough to cover everything. So sometimes we have to collect new data, we have to come up with our own processes, new products, etc. in our research. Now I'm going to move on to the 4 key kind of messages I want to get across, hopefully in the next 15 minutes or so. So the first one is that clean technology aren't necessarily clean. So I'm going to use one example that we looked at in the past, which was this kind of this device that can purify and treat harvested rainwater to a potable standard so that you can drink it. So this was a company that worked with us in the EU project, and they sort of designed this device, and they want to obviously commercialize it. And basically it uses, I won't go into too much details about this, but they use kind of UV lights and ozone to kind of treat the water to bring it up to the we installed a device on top of our innovation building on the Streatham campus, and we tested over I think 1.5 years roughly. So we collect the performance data, etc. It performed quite well in terms of treating the water, and of course we need to do an LCA to see whether environmentally this makes sense. So we looked at the manufacture of this device, all the materials and components involved, its use, of course, and the end of life. What we found was pretty, it was not really surprising to me, but it was definitely a very surprising result for the company. So what we found was that the treated rainwater using this device will cause 4 kilograms of CO2 equivalent per cubic meter of water produced, potable water. Yeah, and that's nearly 10 times the amount for tap water or men's water in the UK. And the main reason for that, as you can see here, so this graph shows the kind of relative contribution of different components and processes to the final carbon footprint. And you can see mostly that's because of electricity use, because this device is really hungry for power, and obviously because it needs to use electricity to treat the water. And that means that a lot of the carbon was emitted simply because of the electricity used. That's for electricity today, or I think it was 2016 when we did the study. We also looked at a few scenarios where we use renewable powered electricity, and that will actually bring down the carbon footprint quite a lot, and in some cases actually lower than the men's water. But that's not going to happen overnight. And actually the company went bust shortly after we published the study, not because of a study, of course, but simply because the device was too niche, I guess. Anyway. I was kind of relieved by that, to be honest. So that's one example, just to show that sometimes, these, technologies that are designed to be clean, they certainly the company who were designing and hope to manufacture these, they really believed in these technologies to be clean. But it turned out not so. And the second point is, I think it's not just the technologies themselves, how we use technology matters. So this is an example of a renewable energy device that we analyzed. So this is a small scale vertical axis wind turbine. And this is getting popular because these turbines are usually small scale and they can be placed, in urban areas. Basically, you can even put on buildings these small turbines, and they're usually, fairly small, a couple of kilowatts. So we used this particular turbine that was installed on a university campus in Poland, and we look at the performance over I think 2-3 years, and see whether, you know, environmentally this was a beneficial thing to do. And again, to our surprise, so here you're looking at the life cycle impacts in relative scale. So the highest one is 100%, and then these are just relative results. So the gray bars you can see here shows the actual performance of the small vertical axis wind turbine on that particular university campus. And you can see in all of the impact categories that we looked at, it generates the highest impacts, even higher than the Polish grid electricity, which is coal-dominated. And the reason for that was, you know, the performance on that particular campus was really poor. It has a capacity factor of 0.5%. And what capacity factor means is, you know, if it's 100%, then you generate 100% of the potential of that, say, 5 kilowatt hour all the time. So basically, what we're seeing is, on average, it only generates 0.5% of its potential, just because of the wind resources on that particular site was not good. And if we use the capacity factor of the average vertical axis wind turbine we found in literature, which is 9%, then you can see, you know, straight away all of the impacts reduced by, you know, 18 times. And that would mean that they are better than the Polish grid electricity, and a lot better. So it's a case of, you know, we need to know how to use the technologies, not simply say that, okay, we use wind energy, then it's all good. It's not. But you might notice here, for this particular category, even if we use it well, it still is much higher than the grid electricity, which is fossil fuel based. So this particular impact category, called abiotic depletion elements, is basically about the raw materials, so the metals that we need to use to produce these technologies. And this is pretty much true for most, I'd say most low carbon technologies that I know of, so batteries, renewables, etc. They all have this issue. They all have higher impacts, usually higher impacts than fossil fuels, because of their demand for metals. So that leads on to my third message, which is, you know, the sourcing of critical materials is really key for net zero future. And because the technologies that we use today, as I mentioned earlier, are so complex, they use so many elements, particularly these clean tech devices. They use many kind of rare and difficult to extract materials, like so REE here stands for rare earth metals. So really the key here is responsible sourcing of these critical metals for not just renewable energy, but you know, pretty much all clean tech. And you know, this topic is never far away. I mean, we are all familiar, I think, with these topics, and there's always these kind of conflicting claims, and these are just a few kind of recent ones. Because we really need to understand and get to the bottom of you know, the impacts of these materials that we use to produce these technologies, and we don't have a good understanding at the moment. So this is why we've done quite a lot of work with working with our colleagues in Cornwall School of Mines. to look at how we extract, how we find and extract and process these rare and in many cases very environmentally damaging materials for our technologies. So we work with mining companies, for example, to look at their operations and help them to understand what the impacts are in their operations. And we develop different tools to help them understand the different aspects of their operation, different impacts over time, because these mines usually have a very long lifetime, decades we're talking about, not just months and years. And these impacts actually can change a lot over its lifetime. So we need to understand these and actually have a good understanding at the beginning of the process, even before the mine starts to operate. And at the end of the day, we have to balance, or certainly for the companies, they have to balance economic and environmental impacts, because they have to have an economic bottom line. And usually they kind of make decisions based on, obviously, the economic aspects. We're trying to develop tools that can help them to make, decisions that are based on not just economic, but also environmental impacts. And we can help them understand that in some cases, these two can be aligned, and we need to find a kind of sweet spot. So all of these work are so important. In fact, Rob here, which was a PhD student, co-supervised by Francis Waugh and myself, after his PhD completed last year, he went on to set up this company called MinViral, and developed software and database to help mining companies to be more environmentally friendly. And I think this is really key that Rob brought our academic research into the kind of practices of our industry, of our businesses, because this is really key, because we can't just do research in the ivory tower. And you can see that MinViral has been doing quite well, actually. In the last couple of years, we've got some investment into it to scale up the company. And that really shows that this kind of research is really valuable to the industry. And I'm really pleased that we've recently got some big projects, new projects to keep on working in this area, because I think this will definitely underpin our kind of net zero targets. So one last key message I want to get across is that we need to look at life cycle performances at different scales. By that I mean, we usually look at things at product scale. And as I mentioned earlier, pretty much all of my previous examples are at product scale. Some of them are at the organization scale or project scale. But we really need to look at all of these scales, because there are different perspectives of the whole system. We might never get to understand the whole system because it's so complex, but we need these different perspectives to cut across as much as possible the whole system, so that we can have a better view. At product level, I think we need to understand everything that we consume as consumers, and also obviously as companies that supply these different products to us. And as a consumer level, we really need to look at our lifestyle, I think, basically what we consume, how much we consume, and what we do afterwards when we finish with them. So here you can see some, quite recent surveys showing that, people are kind of quite keen to do things for the environment, so it's recycling, for example, but at the same time, we generate more and more waste. And it just, doing more recycling is not enough. It seems to me that, it doesn't make sense that you try to recycle more, but at the same time you generate more and more waste to begin with. In fact, I just saw this paper a couple of days ago, really wants to look into the details, but basically what they're arguing is that the more we recycle, the more we will see those plastic waste getting into the sea, which I think is probably very plausible based on some of our own research. So that's a very, I guess, confusing and message here. Should we recycle? Should we do something else? Or maybe the best thing we should do is to reduce consumption. And of course, at the organizational level, we need to hold these companies, we need to hold them to account, because all of these companies, as you can see, I think they are trying to do the same thing. And there's no doubt that some of the companies are trying to greenwash what they're doing. And this is why it's critical that we need to hold them to account and really examine what they do as an organization from a life cycle point of view. Because some of these claims, even though it might be true to a certain extent, it's certainly not so from a life cycle point of view. So for example, Google's claim of carbon neutrality since 2007, but what they're actually saying is that all of the energy that we use comes from renewables. But we know that that doesn't mean carbon neutrality, and that certainly doesn't mean no impact. And same thing here with Tesla, for example. So we need to look at the whole supply chains of these companies to make sure that, when they say they're zero carbon, it really is zero carbon. And of course, from a regional and national level, we need to look beyond the borders. We have all these major countries declaring, zero carbon or carbon neutrality goals by some distant years. But we really need to look at not just what happens within these borders, but their wider footprints globally. And again, basically looking at their whole life cycle. It's really difficult. The more kind of the bigger the scale, the more difficult, basically. So to give you an example, this is probably the last thing I'm going to talk about, to show why we need to look at these multiscales. So we ask this question: is eliminating plastics the answer to the plastic waste problem? So here we use a case study of replacing, hypothetically, the PET bottles, one of the plastics that are mainly used for bottling drinks, replacing this with glass in Cornwall. So this is, as I said, a hypothetical case study. We just want to show, what's going to happen if we do this. So we looked at what exactly happens with our PET bottles, how much we use, how much we throw away, how much we recycle, etc., and where do they go. And we used a lot of high-resolution data that we get from our friends in the Cornwall Council, and also a whole range of publicly available statistics. And as I said, we look at where the stuff goes after they was thrown in the bin or recycling sacks. So it turns out that quite a lot of stuff are recycled, but far away from here. So what we found, again, probably not surprising to many people, is that the PET, so the plastic bottle, overall actually performs better in terms of most of these environmental impacts, and in particular the carbon footprint, for example, is half that of glass, even though we have a very low recycling rate for plastics. So in Cornwall, that's around about 30–35%, whereas glass, we recycle pretty much, well, 80% of them. But even then, the carbon footprint is still lower for the plastic scenario. So I'm happy to take questions, and you're more than happy to look at the paper. That just in the interest of time, I won't go into too much details. So again, this is an example to show that, you know, we need to look at what's in place in our region, you know, the infrastructure and management practices, and also our own consumer behavior, how much we consume, how much we recycle, etc. To be able to look at the actual impacts of some of the interventions that we want to do. So finally, I'm gonna finish by, I guess, sharing a few thoughts on the future directions. I think at the moment, our LCA models is a bit static, but we want to combine our models with more predictive methods, such as economic modeling, agent-based modeling, etc. We are already starting to do that. Obviously, we need data. We need good quality data, and LCA is only as good as the data that you put in. So we need to make more and better use of data from all of these sources, and in particular, I'd like to use more data from citizen science in the future. We need to look at more impacts, and in the impact categories that we have in our impact assessment methods, there are a few key kind of gaps. You know, ecological impacts are not really well represented. We have very little on economic and social impacts. We need to include all of these in the tools that we develop. Of course, as I mentioned earlier, we need to look at different scales, because it helps us to cut across in different directions to understand the whole system. Okay. Right, I think that's enough from me. I probably went over a bit in terms of time. Thank you all, and happy to take any questions.
Great. Thank you. That was I can hear a bit of feedback, so maybe it's a mic thing, but that was an absolutely brilliant talk, Xiaoyu, and rather sobering. I kind of knew that some of that data was out there, but I quite sober. Adding to which that complexity, which you brought out brilliantly, the scale of the complexity of our contemporary economy and its geography is really overwhelming and getting more complicated, not less, over time. So there's loads of really important questions there, and it's brilliant that you're here at the ESI to raise them, because it's all too easy for people to talk about net zero and so on as though it's going to be an easy process and we just need the technology and it's going to solve it. And when you were talking, I was thinking, my question is net zero actually possible? Everyone's got a target in very short period of time, and all the new technologies that we want to use to replace the old technologies still involve huge amounts of materials and energy. And even if it's recycled energy, it still comes from goods that have been made in factories, which involve energy. So we might all be thinking this is the future, but maybe this isn't the future, and net zero is never going to happen. So that was my question, but I think we should go through the ones that are raised in the chat. I think you can see them probably. And maybe actually it'd be best if you stop sharing screen, Xiaoyu, and then we ask people to actually ask their question. So the first one from Fuad Al-Tawil. Do you want to put your camera on and ask your question?
Yeah. Hi. Is that working?
Yeah, brilliant.
Yes, thanks. Excellent talk. And so I'm part of a community energy group in Teambridge, just below you. And we've been looking at this and trying to provide information for our members and the public to understand particularly their carbon and environmental impact. But I was interested, you mentioned the LCA analysis, but you kept referring to input-output calculations. So I was wondering about this environmentally extended input-output methodology versus the LCA methodology of analysis, and which one are you actually using?
Yeah, so a good question. That's a technical question. So when we say LCA, it's a process-based, bottom-up method that we at different technologies. The input-output that you are talking about is a top-down approach, which looks at whole economies usually. So, for example, you have input and output tables for all of the sectors in the UK economy. So it's a very different view. One is bottom up and one is top down. The mathematical structure is quite similar. In fact, LCA is a kind of derivative from the original economic input and output concept, but it's a very different types of input and output. It's one that are talking about physical inputs and outputs rather than economic. So, sometimes we use both kind of top-down and bottom-up and link them together, what we call hybrid LCA, to give both perspectives, but they are different. So I was really talking about the bottom-up process-based LCA.
Thank you.
Thanks. Gemma's got a question.
Hi there. Yeah, thank you so much for your talk. I found it really interesting. I'm a PhD student in economics, and it's linked to my research. So yeah, very interesting. And my question is, do you know if there have been attempts to link LCA research with environmental economics? So, for example, growing biological crops in location water treatment plant X amount per year if pesticides and fertilizers weren't used.
Yeah, exactly. I mean, this is why I said, we need to combine the relatively static LCA approach with some more predictive methods, such as economic modeling. We've been doing this with computational general equilibrium models, but I think there's many other types of economic approaches, such as environmental economics, that we can combine with LCA to answer different questions. Yeah.
Okay, and I've got two questions, one from Stefan, and then maybe we'll go straight to Stuart Walker after that, and then you can answer both at once. That would be good. So Stefan first.
Thanks, Xiaoyu. That was great. Thank you very much. Maybe a predictable question, since we talked about this before, but I just think it's important to have that out there. So as a social scientist, I'd be particularly interested how you would approach having more impacts from the social side. How you would that represented in the model, and you already got thousands of data points. How are you gonna measure even more, as it were? Is it even possible? And I'm thinking, some of these critical materials that you mentioned, the stuff we need for devices like this, come from really, the hinterlands of DC Congo. How are you gonna get data on what's happening, in very remote local areas, socially, child labor, toxic material dug up with bare hands. How are you going to get this into the model, as it were? Thanks.
Thank you. I think that there's two kind of aspects to your comments and questions. I think the first one is how we get across this message, or often very complex picture, to particularly the public, I guess. I think that's a question that I've been battling with for many years, because I struggle to do that, to be honest. Not just the public, but even some of the decision makers that we want to influence, like governments and some businesses. So I think we need to work with social scientists in this particular area to try and find better ways to communicate this and to find the kind of sweet spot of, you know, not losing too much details, but again, make people understand what we're saying, because, you know, if it's too complex, as you say, I mean, people might just shut off their brain and don't do anything. And the second one is how do you get the data for these complex things? I mean, we're not doing all of these things ourselves. We, as I said, we use these databases that are being constantly sort of expanded, and there's lots of more data being put in these databases all the time. So it's a very huge community actually working together to collect all of these data, maintain all of the databases. And that's how I think how we do it. And in the future, I think, as I mentioned in one of the previous slides, we're going to need to use these to help us to collect some of the data automatically and probably in better ways, I suppose.
Stuart Walker had a question on exactly that topic. So have we answered it, Stuart, or do you want to actually say something?
No, I think you answered it. It was just about how you get across that kind of complexity to the public. Everybody likes a headline that says electric cars are better or electric cars are worse. How do we get across, you know, in some cases they're better, in some cases they're worse? Or it's the, you know, everybody's least favorite answer to the question is it depends, isn't it? And how can you kind of express that? Is yeah, I think, as you said, it's something that a lot of people in a lot of fields probably are still grappling with, and we will continue to do so. Yeah,
definitely. We have got time for one final question. Marcus has raised something about recycling, but I actually had a question as well about scale and whether localizing our economy and shortening our supply chains is a way to maybe help with some of this, so we reduce the complexity and then you can really communicate as well about the impact you're having, because you can see it more. So Cornish Lithium seem to be doing quite a good job at saying they want to bring back the lithium business to Cornwall so that it's a local industry, and then you can actually try to keep more of the value in the area and trace what's happening to all the product. So I wonder what you thought about localization, or is that just kind of naive romanticism when our world is actually incredibly globally interconnected?
Yeah, I think this is a big question. First of all, I think there's no one size fits all answer to that. So it's not going to be a simple answer. I think it will always depend on the context. In some cases, you might find localism is better for the environment and socially as well, whereas in some other cases it's not. Yeah, it's never going to be a simple answer. You know, this is good or not. For example, if you want to grow all of our food, for example, in the UK, and the UK's climate is not good for quite a lot of crops, which is why we don't grow them here. And if you want to grow them, all of our food in the UK, then you need a lot of energy, you need probably a lot of fertilizers, etc. And that's probably not going to be a good thing for the environment. And you know, it's difficult. We have to look at all of these case by case. I'm afraid there's no simple answer in this. And maybe just to quickly touch on your net zero question, because I think it's really important. I do believe it's still possible. It is possible, but it might be more difficult than everyone or currently thinks, because it seems to me that a lot of the thinking around this is that if we have, you know, all of our energy systems come from renewables and all of the cars become electric, we're going to go net zero. I don't think it's going to be as simple as that. I think we definitely need some nature-based solutions that offers negative emissions. You know, things like you know, growing more trees, I suppose, not just capturing you know, artificially capturing CO2 from the air, because that usually always needs energy and other inputs. But we need more kind of nature-based solutions, I think. It's definitely possible for net zero to happen, but we're going to need to try much harder than we are trying now.
And maybe the geography of that is that some places have to be net negative, not net zero, but go further so that you can balance that out. So it's an interesting question. Yeah. And we're almost out of time. We've had lots of comments in the chat saying it was a brilliant talk, which it was. We need to carry on having this conversation because in a way what you're doing underpins everything that is critical to the debate about sustainability. So we need to find a way of building on what you're doing and sharing it much more widely. So I think that's a project for the ESI in the next year or so. But a fantastic talk. Great, everybody's here. If there's anything anyone wants to raise, you've got a minute to quickly put your camera on and say it. No? Well, thank you, Xiaoyu. Big round of applause.
Thank you.
And carry on having the conversation. Yes, so thank you very much.
And
thank
you, everyone,
for coming too. We're going to put this on the website as well, so if you want to catch up later on or share it with people, then it will be on the website in a day or two. So great. Thank you all very much and see you soon. Okay, bye.